Today I am going to explain set theory. Now first we need to know that what is set. A set is a well-defined collection of objects or elements. Suppose we say that the number of good students in a class. Now it can't form a set because the number of students means they are good in which respect? Are they good in singing? Or they are good in dancing, or they are good in academics. So we need to specifically mention the things that the students are good in maths or the students are good in sports, like this. Then it can form a set. Set should always be represented with capital letters like this and must be enclosed with braces, curly brackets like this. Now the example is like this. A is a set of all the even numbers which is less than or equal to 20. Less than or equal to. Now here I am specifically mention that A is a set of all the even numbers, and all the even numbers, which even numbers? That are less than or equal to 20. So now this is the descriptive form. Now I am written this in the variable form or the set builder form. A in the curly brackets, x variable, I have taken the variable as x, and x equal to n, where n is an even number less equal to 20. So it can be 2, 4, so it should be like 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20, as this is less than or equal to 20. So I couldn't take after 20. Now representation of set. How can we represent the set? It can be represented in description method, in roster notation or listing method, or set builder method. Now what is the descriptive form? The set of all vowels in English alphabet. This is the description. Now the set builder form, in the set builder form we take the variable like x. Now x is a vowel in the English alphabet. Now in the roster form we just put all the objects or the elements by putting the comma between them like this. The vowels are a, e, I, o, u, so we need to write within the curly brackets a, comma, e, comma, I, comma, o, comma, u, like this. Now the second example. The set of all the odd positive integers less than or equal to 15. This is the description. Now the set builder form, I have taken x as variable and write it like this way. X is an odd number and 0 less than x less equal to 15, like this. We have put the limit here so that we can clearly define the set. Now from 0 to 15 we can write the odd number like this way: 1, 3, 5, 7, 9, 11, 13, 15. Now the types of set. Different types of set. First one is finite set. What is finite set? The number of elements is finite. When the number of elements in a set is finite, then or we can count the number of elements, then it is called the finite set. Example: a set of months in a year. We all know that the number of months in a year is 12, so it's countable, and we can write like this way: January, February, March, April, May, like this. Okay. Now infinite set. The number of elements are infinite, so that we couldn't count the number of elements. If we write that a set of all points on a line, there can be infinite number of points on a line. We couldn't count that. So this can form an infinite set. Now the empty set. When there is no elements in a set, it is called empty set. Like the set of integers that are both even and odd. We couldn't find any kind of integer which can be both even and odd. So this description is for empty set. Now singleton set. Singleton set is when there is only one element in a set. Set of even prime number. The even prime number is only 2. So this is a singleton set. Now equal set. Equal set. Equal means we must take two things to make it equal. So two sets are equal if they have same elements. Example, A equal to 2 minus 3 comma 7 comma, there are 4 elements in a set, 2 minus 3 7 8, and in another set there is minus 3 7 2 8. So we can say that these two sets are equal. Now equivalent set. Equivalent set are those where the number of elements are equal. The elements are not the same, but the numbers are same. Example, P equal to 2, 11, 22, 33 and Q 7, 21, 51, 30. So there in both the sets there are 4 elements. So P is equal to Q, and the number of elements of P is equal to number of elements of Q. So they are equivalent set. Now power set. A set of every possible subset is called power set. Now, so to understand power set, we need to know about the subset first. What is subset? Subset. A is said to be a subset of B if all the elements of set A are also present in set B. Like this. If B equal to XYZ and A equal to XY, then we can say that A is the subset of B because all the elements of A is also present in B, and here A is also called the proper subset of B. A subset is denoted by this symbol and read as is a subset of. Now the proper subset and improper subset. If A equal to 2, 3, 4, then proper subsets are including the null set. Excuse me. We can say that the proper subsets are null to every possible subset 2, 3, 4, 2, 3, 3, 4, 2, 4. These all are proper subsets. But we couldn't take 2, 3, 4. The same elements. If the elements are same, then it's called improper subset. So okay. Now we can understand power set. A set of every possible subset. If A equal to A, B, C, then the subsets of the set are null set A, B, C, AB, CA, ABC. So proper subset of A are including the null set all the possible subsets like A, B, C up to ABC, and the numbers here in the next video I will explain the cardinality. Okay. Now the universal set. Any set that contains all the sets under consideration. Any set that contains all the sets under consideration is called universal set. Like let us consider 3 sets like A, B, C. A equal to 1, 2, 3, B equal to 3, 4, 6 and C equal to 6, 11, 12, 14, 15. Then the universal set is 1, 2, 3, 4, 6, 11, 12, 14, 15. It includes all the elements of the 3 sets.